So good morning all. So welcome back again in the second session of disaster management. So in previous session we have started with the tsunami, its origination, its causes, its adverse effects. We have seen some of the adverse effects of it also. Actually, due to some at the last moment, due to some problems in that internet, the lecture got suddenly closed. So sorry for that from my end. So let us continue with this session. So I am going to share a video over here that elaborates about the origination again, those who were not there in the previous session. So please go through it. I hope the screen is visible to you. Okay. So let us go through this.
In 479 BC, when Persian soldiers besieged the Greek city of Potidaea, the tide retreated much farther than usual, leaving a convenient invasion route. But this wasn't a stroke of luck. Before they had crossed halfway, the water returned in a wave higher than anyone had ever seen, drowning the attackers. The Potidaeans believed they had been saved by the wrath of Poseidon. But what really saved them was likely the same phenomenon that has destroyed countless others, a tsunami. Although tsunamis are commonly known as tidal waves, they're actually unrelated to the tidal activity caused by the gravitational forces of the sun and moon. In many ways, tsunamis are just larger versions of regular waves. They have a trough and a crest, and consist not of moving water, but the movement of energy through water. The difference is in where this energy comes from. For normal ocean waves, it comes from wind. Because this only affects the surface, the waves are limited in size and speed. But tsunamis are caused by energy originating underwater, from a volcanic eruption, a submarine landslide, or most commonly, an earthquake on the ocean floor, caused when the tectonic plates of the Earth's surface slip, releasing a massive amount of energy into the water. This energy travels up to the surface, displacing water and raising it above the normal sea level. But gravity pulls it back down, which makes the energy ripple outwards horizontally. Thus, the tsunami is born, moving at over 500 miles per hour. When it's far from shore, a tsunami can be barely detectable, since it moves through the entire depth of the water. But when it reaches shallow water, something called wave shoaling occurs. Because there is less water to move through, this still massive amount of energy is compressed. The wave speed slows down while its height rises to as much as 100 feet. The word tsunami, Japanese for harbor wave, comes from the fact that it only seems to appear near the coast. If the trough of a tsunami reaches shore first, the water will withdraw farther than normal before the wave hits, which can be misleadingly dangerous. A tsunami will not only drown people near the coast, but level buildings and trees for a mile inland or more, especially in low-lying areas. As if that weren't enough, the water then retreats, dragging with it the newly created debris and anything or anyone unfortunate enough to be caught in its path. The 2004 Indian Ocean tsunami was one of the deadliest natural disasters in history, killing over 200,000 people throughout South Asia. So how can we protect ourselves against this destructive force of nature? People in some areas have attempted to stop tsunamis with seawalls, floodgates, and channels to divert the water. But these are not always effective. In 2011, a tsunami surpassed the flood wall protecting Japan's Fukushima power plant, causing a nuclear disaster in addition to claiming over 18,000 lives. Many scientists and policymakers are instead focusing on early detection, monitoring underwater pressure and seismic activity, and establishing global communication networks for quickly distributing alerts. When nature is too powerful to stop, the safest course is to get out of its way.
So this was about the tsunami generation. Now, as in this video also, they have mentioned about the 2004 Indian Ocean tsunami. So why it was so deadly? There is a video explaining that. So that we are going to have it today also.
लगा के देखो।
Tsunamis are one of the worst forms of natural disasters. As an example, the 2004 Indian Ocean tsunami, which had waves as high as 30 meters tall, once had killed approximately 230,000 people in 14 separate countries, making it one of the worst natural disasters ever recorded.
So please note down these countries which were affected by this 2004 Indian tsunami, Indian Ocean tsunami. You can take picture of it also.
Tsunamis, unlike normal waves, which are caused by the winds and tides of a gravitational pull, are caused by extremely large displacements of water. In the case of the Indian Ocean tsunami, it was caused by a large undersea megathrust earthquake that measured 9.2 in magnitude. This earthquake occurred along a 1,600-kilometer subduction zone where the Indian plate slid under the overriding Burma plate. As the overriding Burma plate bulged under strain, tectonic uplift occurred before eventually the plate slipped, causing a massive amount of energy to be released and thus causing a tsunami. This earthquake, which displaced an estimated 30 cubic kilometers of water, created waves with an energy equivalent of 5 megatons of TNT, which is more than twice the total explosive energy used during all of World War II. On average, 2 tsunamis occur per year, and approximately once every 15 years, a very large destructive tsunami strikes. You may be asking then, what made this particular earthquake and subsequent tsunami just so deadly, and how can this be prevented in the future? One reason is the close proximity of the earthquake to land and the extreme speeds at which a tsunami moves. The hypocenter of the earthquake was approximately 160 kilometers off the western coast of North Sumatra within the Indian Ocean. Just 20 minutes after the earthquake occurred, the first waves were arriving at the northern tip of Sumatra, instantly killing nearly 100,000 people. Then, an hour and a half later, the waves hit Thailand, resulting in similar death and destruction. These waves continue to expand outward from the epicenter of the earthquake at a rate of about 500 miles per hour, or about the speed of a commercial jetliner, hitting all of the surrounding land masses and bringing with it extreme amounts of destruction. The second and related reason as to why the tsunami was so destructive is that despite having some amount of time, although limited, between when the initial earthquake occurred and when the tsunami arrived, many of the countries hit by the tsunami were completely taken by surprise. At the time, there were no tsunami warning systems located in the ocean to provide any advanced warning, making it impossible for anyone to know what was about to occur. And all that being said, tsunami detection is not easy, as often the water disturbances occur in very deep water in which earthquakes may not be easily felt. In deep ocean water, for instance, a tsunami forms only a low, broad hump that is barely even noticeable, even for a passing ship. However, near the coastline, where the water becomes shallow, the tsunami slows down and forms the large destructive waves that we typically think of when we hear the word tsunami. These waves, which can be as tall as 30 meters once hitting land, can travel several kilometers inland, causing major death and destruction. The first signs of a possible tsunami are obviously the earthquake itself. However, tsunamis can strike thousands of kilometers away from where the earthquake occurs. Additionally, if the tsunami is caused by a volcano or a landslide, earthquake sensors alone will not be much use in the prediction of where the tsunami is to occur. Many analysts claim that the disaster would have been mitigated if an effective warning system would have been in place, such as the one that's located in the Pacific Ocean already. The National Tsunami Warning Center, which was founded in 1967 and is run by the U.S. National Oceanic and Atmospheric Administration, is the premier tsunami warning system in the entire world. This system primarily monitors the Pacific Ocean for tsunamis, as it is particularly susceptible due to the fact that it is home to a region known as the Ring of Fire. This ring is a direct result of the collision of tectonic plates and is home to roughly 90% of all earthquakes and 75% of all volcanoes in the entire world, thus giving it an increased risk for a tsunami to occur. The primary component of the tsunami warning system is what is known as DART, or the Deep Ocean Assessment and Reporting of Tsunamis. This system enables instant and accurate tsunami forecasts by monitoring the ocean floor. The DART system itself is made up of three parts: the pressure recorder anchored to the bottom of the seafloor, a moored surface buoy, and an acoustic transmission link that connects the seafloor and the surface modules. During normal operation, the system will steadily measure the water pressure at the sea floor. Since there is a direct relationship between water pressure and the height of the water column above it, the water column can be monitored over time for any anomalies simply by measuring the water pressure. If a large wave passes over where the DART system is located, it will measure a higher water pressure and thus a higher water level. If the calculated water level is not within recent data averages or the nominal water level, the system will initiate the tsunami alert process, indicating a possible tsunami threat. The system will first transmit an alert to the surface buoy using underwater acoustics, which will then pass this alert to a satellite and on to the Tsunami Warning Center headquarters for further analysis. After further analysis, and if a tsunami is indeed occurring, alerts via text messages, emails, and other emergency alert systems can then be sent out to the general population, alerting them to evacuate and head to higher ground. Today, the tsunami warning system consists of nearly 40 separate DART stations scattered around the Ring of Fire in the Pacific Ocean, as well as several stations in the Caribbean and off the Atlantic coast. As a result of the success of this system, many internationally coordinated systems have now spawned as a result, including many regional systems as well. For example, in response to the Indian Ocean earthquake and resulting tsunami in 2004, the Indian Ocean Tsunami Warning System was agreed upon at a United Nations conference in 2005 and has been operational since 2006. Today, this system has a total of 7 DART stations scattered throughout the Indian Ocean. In addition to this, there is also the Joint Australian Tsunami Warning Center, composed of 5 DART systems, and the South American system, composed of 8 DART systems. These systems, although managed independently, often work together and share data in an effort to provide as much advanced warning of potential tsunamis as possible. By relaying advanced warnings to people, the necessary steps can be taken to evacuate to higher ground and get out of harm's way as soon as possible. Hopefully, these systems in future land expansions will be able to prevent another horrible natural disaster like the 2004 Indian Ocean tsunami from ever happening again. Let me know in the comments below what you think about the tsunami.
So, this was the video about the tsunami detection system and the 2004 Indian Ocean tsunami. So, any questions from here? Any kind of question? So those who have not written their enrollment number for attendance, kindly note it down to avoid last minute rush. So in the last session, which was suddenly breaks down, we were discussing about the adverse effects of the tsunami. So one of the adverse effects are, as we have seen in the video, that in less than 30 minutes, it will cause the damage, can erase anything which is coming onto its path. And normally flooding effect, tsunami that causes the major destructions in the human settlements, roads and infrastructures, thereby disrupting the normal functionality of the society. So withdrawal of the tsunami causes major damage as the waves withdraw towards the ocean. They strip away the foundations of the building, which get destroyed, house get carried away, damages to ports and airports, if any. Apart from that physical damage also, there is a huge impact on the public health system. So death mainly occurs because of drowning of as water goes into homes. So many people get washed away or crushed away in the giant debris that fall, that comes along with the sea waves. So there are few evidences which shows that tsunami flooding has caused large-scale health problems also, that availability of drinking water being a major problem in the areas. Sewage pipes might get damaged and open wells and other groundwaters will get contaminated due to the debris of the sewage or the salt water. So now these are some of the recorded earthquake tsunamis that was year 1524, and the date is not mentioned because it was too far an ancient data, we can say, which is near Maharashtra, which is in Maharashtra near Dabhol. So sufficient data was not available. Even you can see in 1762 near in Myanmar, in 1819 in the Kutch of Run of Kutch, that is Gujarat, in 1847. But till 1847, there is no sufficient data available for this kind of disasters. So in 31st December 1881, earthquake of 7.9 Richter scale in Nicobar Island, which is the entire east coast and Andaman Nicobar Islands. 1 meter tsunami were recorded at Chennai also. So that subsequently in 1883, explosion of Krakatau volcano in Indonesia that we have discussed in the previous session. That was volcanic. That was tsunami due to volcanic eruption under the seabed. So that East Coast Indian was affected. 2 meter tsunamis were recorded there. In 1941, 8.1 Richter scale earthquake in Andaman was there. So East Coast of India was affected. Height of tsunami was not available. In 1945, due to the 8.5 kilometer square earthquake, distance of about 100 kilometers from south of Karachi, west coast of India from north to Karwar was affected. So 12 meter of tsunami was felt at Kandla port. So and the disastrous tsunami that occurred in 2004 on 26th of December. Bandra, Indonesia, Banda, Indonesia, Tamil Nadu, Kerala, Andhra Pradesh, Andaman, Nicobar Islands, India, Sri Lanka, Thailand, Malaysia, Kenya, Tanzania. Almost around 2 lakh people were killed. So the east coast of India was affected. The wave measured around 10 meters high, killing more than 10,000 precious lives in India only, where in other countries the total loss of life was around 2 lakhs. So please note down this or take out the picture of it if you want. And if you have any question, you can ask me. So in previous, some of the discussion on earthquake that, someone has asked me that why the, African continent has not any severe kind of, tectonic movements, because in that region, see, there are many causes of earthquake that we have already discussed. So I have searched about it, about the uh, South African content or African, plate, that no major, movement on that particular plate was observed. Or as in that video that I was showing you today, in the course of tsunami, that you have seen the Pacific Ocean, ring of fire, which is more, or, which I can say is a predominant zone where earthquake occurs very often. So due to that, that tectonic plates are keep moving aside from each other. But, as in African content or African plate is not that much active, so there is no any major earthquake has recorded, or there is no major fault has occurred anywhere in that particular, region itself. So any question up till here from your end? So now the risk reduction measures that, we are talking about. So while it is of course not possible to prevent a tsunami, that because it is not in hand of, humans, because it's a natural disaster. In certain tsunami prone countries, some measures have been taken to reduce the damage caused on shore. So Japan has implemented an extensive program of building tsunami walls up to 4.5 meter high in front of populated coastal areas. So other localities have built floodgates and channels. In populated, like we have seen in the video itself. So, however, their effectiveness has been questioned, as tsunamis are often higher than these barriers. So, for instance, the tsunami which hit the island of Hokkaido on 12th of July 1993 created waves such as 30-meter tall. It is around 100 feet tall, as, a height of 10-story building. The port town of Eone in Hokkaido was completely surrounded by a tsunami wall, but the waves washed right over the wall and destroyed all the wood frame structures in the area. And the wall may have succeeded in slowing down and moderating the height of tsunami, but it did not prevent the major destruction and loss of life. See, this kind of sea walls can reduce the effect or can moderate the effect of tsunami waves, but, it cannot totally eliminate the effect of, drowning of the sea wave, because we can't estimate or we can't predict the height of the tsunami waves. They have kept it for 30 meters as 10-story building. they have kept it around below that so that water will spill over from that height also and get its destructive effect passed over. So what kind of site planning and management or land management we can have in terms of these tsunami reductions? So within the broader framework of a comprehensive plan, site planning determines the location, configuration and density of development on particular sites and is therefore an important tool in reducing tsunami risk. So the designation and zoning of tsunami hazard areas of such open space uses as agricultural parks and recreation or natural hazard areas is recommended as the first land use planning strategy. This strategy is designed to keep development at a minimum in hazard area, so there should be less chances of any loss of life in areas where it is not possible to restrict the land to open space uses. Other land use planning measures can be used. These include strategically controlling the type of development and the uses allowed in hazard areas and avoiding high value or high occupancy uses to the greatest degree possible. So where this land use planning cannot be implemented or cannot be restricted. So in that particular kind of area, a strategy can be developed that what kind of development they will allow in this kind of hazard prone areas so that we can avoid having high value or high occupancy structures with the greatest degree of possibilities of being heated or being risked in that kind of zone prone that disaster prone zone is if it is possible. So engineering structures that most of the habitation of the fishing community is seen in these coastal areas. So the houses constructed by them are mainly of lightweight materials without any engineering inputs. So instead of this, that low cost or lightweight materials which are used for this for the building of their habitation of their houses or the fishing community, we can construct some engineering structures also. So in that, therefore, there is an urgent need to educate the community about the good construction practices that they should adopt, such as site selection, avoid building or living in buildings within the several 100 feet of the coastline, as these areas are more likely to experience damage from such kind of disasters like tsunami, and construct the structure on a higher ground level with respect to mean sea level and elevate coastal homes that most tsunami waves are less than 3 meters in height. Elevating houses will help reduce damage to the property from most of the tsunami that has occurred. Okay. Any questions from this? Yes, any questions? So again, I am requesting you to write down your numbers to avoid last minute attendance problems, those who are present over here. So construction of water breakers to reduce velocity of waves, that one of the kinds are that sea walls that have been constructed. Use of water and corrosion resistant materials for construction. Construction of community halls at higher locations which can act as shelters at the time of disaster. Flood management, so flooding will result from a tsunami, so tsunami waves will flood the coastal areas and the flood mitigation measures could be incorporated. So this is about the tsunami itself. So in this video or in this session, we have seen about some of the tsunamis that have recorded in past data. Then we have discussed about the risk reduction measures. So what Japan has implemented by constructing this kind of tsunami walls in high in front of the populated coastal areas. Other localities have built floodgates and the channels to redirect the water from incoming tsunamis. So in site planning and land management, we have discussed that a broader framework or the comprehensive plan can be made, which is about the location, configuration and density of development nearby on this kind of particular locations, which are important tool in reducing the tsunami risk. So designation and zoning of tsunami hazard areas for such open spaces uses agriculture, parks and recreation or natural hazard areas is recommended as the first land use plan strategy. So we should avoid high value and high occupancy usages. And also one can have the engineering structures because most of the habitants nearby the shore area are from fishing communities and they do not have their buildings made up of proper engineered in outputs. So there should be so in site selection, that is avoiding the buildings or living in buildings with several hundred feet the coastline, as these areas are more likely to experience the damage from the tsunamis. And construct the structures on a higher ground level so that it can reduces the damage caused by the tsunamis. Construction of water breakers that reduces the velocity of the water. Construction of community halls which can be used as shelters during this kind of disasters. And flood management, that is flooding will result from a tsunami. The tsunami waves will flood the coastal areas and the flood mitigation measures that could be incorporated. So that is about the today's session. We have discussed about the tsunami, causes of tsunami, risk reduction factors, past data, what kind of mitigation measures we could have in our in view to this particular kind of disaster. So again, I am requesting all to write down their numbers if they have not written. And one more instruction is there. I have shared one Google form link with you yesterday on your institute email ID. you can only able to open that or access that link with your institute mail ID that is you are having as a student. So open it up, fill it up by 15th of September. It is about your presentation topic. And if you have any issues regarding that, then you can come and meet me personally in civil engineering department. My office number is MB054. So if you find any kind of problem over there, that you can come to me personally, and we will try to resolve it. Otherwise, just use your student mail ID. Okay. So any more questions for that? And yes, the presentation will be for individuals. Okay, it is not a group activity. It's not a group activity, it's an individual activity. So everyone has to prepare the presentation and submit it individually. It's not a group activity. So thank you all for today's session. Here I am ending this session. Now from next session, we will start with another kind of hazard, that is cyclone. So thank you all. Have a great day ahead. Thank you again.